Hello class. Today we're going to do chapter 7, section out, and the direction is just say, add or subtract. And the rule is, it's kind of like just adding 5x and 2x. This has to be the same, and it stays the same. So think of, I have 5 root 15s, and I'm going to add 2 root 15s. So now I have 17 root 15s. Okay? And that's true with about anything. So say I even have the cube root of 2y. Subtract the cube root. Let's see. I meant to fit a number in there. So I'll put minus 4 times the cube root of 2y. So once again, the radicand has to be the same. And the root has to be the same. And it is. So you just subtract. Now, if you saw something like this, square root 10 minus, say you had the cube root of 10. Now the roots are different. So if the root is the different or the radicand is different, all you do is simply say it can't simplify. So they have to be the same to add them. Now most of your homework won't be quite that easy. It could look more like this. Now as it is, we can't do anything to that problem. But guess what? If you simplify, which you've already learned to do, you will be able to do it. So just break it down. 25 times 2, which we know is 5 times 5. So there are 2 5s, and since it's a square root, I can take that out because there are 2 of them, and square is 2, and left inside is that 2. Let's break down the 18. 9 times 2, which is 3 times 3. So once again, there are 2 3s, so I'll pull that out. And don't forget, if I pull the 3 out, and there's already a 5 there, they multiply, okay? And this 2 stays inside. And now they have the same radicand and the same root. So I can combine them. 5 root 2s plus 15 root 2s gives me 20 root 2s, okay? Let's try this one. This one has some variables in it, just to make sure we're good at those too. So, breaking down 8, I know that's 4 times 2, which is 2 times 2, and yet there are exactly 3 2's because 8 is a perfect cube. The cube root of 8 is 2, so I pull that out. Now, remember how we did variables. Think of the closest thing to 5 that is divisible by 3, and that would be 3. And so, to add up to 5, I need 3 root y to the third plus y squared. Same as having 3 y's, so it's like you're pulling that out. Or you can go power divided by root. 3 divided by 3. So I take 1 y out, either way you think of that. And left inside, we still have that y squared. So same thing with this one. I've got 9 times 3, which is 3 times 3. And oh, look, another perfect cube. The cube root of 27 is 3. And they did the very same exponent for the y. So the closest thing to 5 that is divisible by the root 3, that's not bigger than 5. So the cube root of y to the third is y, and left inside is this y squared. So I'll circle this because it came out right there. Y to the third, remember we're thinking power divided by root, and that's what comes out right. They just happen to be like terms, so I can add them, and I know these have to be the same, and they are, so they stay the same. They have to be the same, and they stay the same. And then 2y plus 3y is 5y. Now, when you get good at simplifying and adding, they're going to move you to multiply. So here's an example of a multiply problem. This first one, they're just going to have you distribute. So you know when you see this that you're going to go the square root of 2 times 6 and the square root of 2 times 10. So you have to remember your rules. Since this is a square root and this is a regular number, you just go 6 times root 2 when you multiply those together. And of course you could write root 2 times 6, but we typically write the number in front so people won't think it's inside the radical. And the 2 times root 10, remember that if the root is the same, they're both, I can just multiply what's inside. Oh, that's the same as, I can take the 2 out, leave the 5 in, and I've got 6 root 2 plus 2 root 5. Sometimes you'll be able to combine those, so make sure you simplify as far as you can. The next thing they could do to multiply is they could give you one like this. They could give you a binomial with a radical and one without a radical, so it looks something like that. Oh, this should be a 2. I almost made that a 7. Alright, let's go ahead. We know the word. We're going to FOIL this, right? So FOIL. First times the first. They're both square roots. So square root 3 times square root 2 is square root 6. One is not, so I just put 7 root 3. This one, they're both in square roots, so I can multiply them. And a negative times a positive is negative. And 5 times 2 is 10. And then last times the last. So we just did that. That's right there. Now I'm going to do the last times the last. So I have 7 times negative root 5. So I get negative. So they just look like that. And then just check for any like terms. And there aren't any. So you can't combine anything. So you're done. That's your answer. I'm going to do one more problem. They try to trick you with something like this in your homework. And they think some people might just square this and square this. But you know, if there's a plus or minus sign, the whole thing, that is square root 3 minus 7 squared. So once again, you have to FOIL. So here we go. First times the first, outside times the outside, inside times the inside, last times the last. And now we have 2 with the same radicand. They're both square root 3. So I can combine those and I get negative 14 root 3's. Don't forget the rule. They have to be the same and they stay the same. You just add the coefficients. And I know that the square root of 9 is 3. So I'm going to write that tiny because look, I'm going to go ahead and add 3 plus 49. And so I'll have 52. And that's correct in either order, but they will typically write the real number first and the radical number second. Okay? So, by the way, I've seen problems, and there have even been add and subtract problems in the final exam. So this could totally be on your final. It will absolutely be on your next test. So make sure you know it well. Good luck. Oh, my paper was almost off the screen. Can you see that? 52 minus 14 root 3.